Trig day 3. What do we want to know? We want to know this missing angle. We're given two sides. This question is not asking us for the third side, although we can certainly find it if we wanted to. We just want to know what this angle is here. What would you guess that angle would have to be? If I asked you to throw out a number, hopefully you would say somewhere less than 90 and greater than 0, of course. This is going to be an acute angle. If you guess that angle is 100 degrees, well, I don't think that looks like 100 degrees. And plus, when you add it to 90, you'd get above 180 degrees. It couldn't be a triangle. So this is an acute angle. I would guess somewhere around 20 degrees, 30 degrees, 40 degrees, somewhere in there. How do we find it? We start by labeling our triangle. We're starting down here. How do you know where to put the person? It's wherever the angle marker is. We label. We've got the opposite, and we've got adjacent. Hypotenuse has no number on this side. We can label it. We're not going to use it this time. So we say, I see the opposite, and I see the adjacent. What trig function goes with opposite and adjacent? It's tangent. So we write down tangent of whatever that angle is, little theta mark right there to mean what angle, is equal to the opposite over the adjacent. So let's do some replacing here. Tangent of theta, I still don't know what theta is, but I do know what the opposite is. That's 7, and I do know what the adjacent is. That's 12. If I divided those, you would get a decimal answer that looks like what the tangent would be, but we need to know what the angle is in this case. How do we find it? On your calculator, you are looking for a button. Right above your tangent button, you'll see a button like this. Here's your calculator. It probably says something like tangent. Somewhere right by it, you will see a little inverse button, a little tangent with a little -1. We read this inverse tangent, not tangent -1, but this is the button that you want to push. You want to write down tangent -1, and then we're going to put that fraction in there and see what happens. Most calculators, it'll look like this. It'll say inverse tangent, tangent -1, then it'll give you some parentheses. And instead of the fraction bar, we can probably just put divide in there. 7 divided by 12. If you have a fraction button on your calculator, you can probably use that too. It will be the same thing. And then we push enter, and hopefully this will tell us a number that looks something like an angle. I don't have a picture of our calculator here, but you can jump over to a lot of different websites. I've found Wolfram Alpha, which is a very good math website. You can type nearly anything into this. It understands almost anything you will type. So we notice we wanted the inverse tangent of 7 over 12. What does this say? Oh, there, it looks just like we would type it into our calculator. Inverse tangent of 7 over 12. And this has told me 0.5280. That's our decimal approximation. But we don't want that. We want degrees. Converting to degrees says 30.26. That's the answer we want. If your calculator's in degree mode, it's going to tell you 30.26. That's what we're looking for. It's traditional to round our angles to the nearest whole angle in this case. So we could say that our missing angle theta is equal to 30 degrees. You can put 30.0 if you want. If we take a look at this, and it says 30.26, you either round that up to 31 or down to 30. Since 0.26 is less than 0.5, we round it down to 30. A lot of different information on this particular website, but you could probably type it into Google too. It would work just the same. What else? Let's do another one here. Notice I skip around on all these because we can't do every example. You'd be watching this video forever. Let's take a look. We're given a right triangle. This time we're starting with angle A down here. Here's you standing on angle A. And you say, this time I know the hypotenuse and the adjacent side. But I want to know what that angle is. Looks a little bigger this time. You might not guess something like 20 or 30 degrees, but we'll see. You can label the opposite if you want. We notice there's no number over here, so we're not going to use it for this problem. So what do we got? We got the hypotenuse, and we've got the adjacent. What trig function is that? It's cosine. We write down the cosine theta is equal to the adjacent side 4 over the hypotenuse 12. How do we find what angle that is? We are looking for the inverse cosine button, so you go back to your calculator and you find whatever says cosine, and usually nearby there's some button that says inverse cosine looks like cosine minus 1. We call this inverse cosine. So we type in our calculator inverse cosine, and then it usually gives you some parentheses here, and you write 4 over 12. You can use the fraction bar if you want. It should say the same thing. Inverse cosine of 4 over 12, you close up your parentheses, and hopefully it'll give you something that looks like an angle, like a number between 0 and 90. This looks like on the larger side, closer to 90. I'm hoping like 80, 70, somewhere in there. So inverse cosine of 4 over 12. This website, I'll just go over here and write inverse cosine of 4 over 12. Press enter. What does Wolfram Alpha tell me? Inverse cosine of 4 over 12, that's what I said. It even understood me all the way up there. We don't want this decimal approximation. We want the degrees. It says 70.53. 70.53. So break down here, and we'd say that theta is equal to 70.53. It's traditional when your answer is in degrees to round to the whole nearest degree. So we take a look here, and then we say that number is 5 or above. We would round up. We would say theta is equal to 71 degrees. Not a big deal if you forget to round that. 70.53 is pretty close to 71, even when we're talking about degrees. But sometimes our instructions will say to round to the nearest tenth, and sometimes the nearest whole number. We just got to be aware of what we're being asked to do.